Konnichiwa. My name is Cynthia Thomas. I'm a systems engineer at Midokura. Thanks very much for coming today. Today the talk is entitled Removing the Blindfold from SDN. So talking about SDN technologies, old and new operational tools, and some things that we can use tying in networking with OpenStack clouds. So first we'll talk about legacy network infrastructure, how they were architected. You're probably somewhat familiar, those network engineers in the crowd, and how they were built at a time where a majority of the workloads were physical workloads. We'll talk about some of the advantages using Mesonet as a network virtualization overlay. Mesonet is actually a Neutron plugin for OpenStack. Finally, we'll wrap up, try to give you a glimpse of Mesonet Manager, and talk about some of the operational tools for allowing more insight and removing that blindfold after using encapsulation technologies like VXLAN, GRE, for example, and some of those operational tools. So those of you who might be familiar, the typical three-tier architecture using spine, a spine leaf type architectures. Majority of workloads were physical, so a lot of the workloads and traffic pattern flows were north and southbound. As the growth towards virtualization, containerization happens, we have more east-west traffic-bound flows. So architected at a different time, let's say. So those previous architectures were architected for physical workloads, north-south traffic-bound flows, typically with proprietary hardware and their inherent technologies for sniffing packets, for example, using RSPAN, things like that for troubleshooting. We'll talk about some of those, those bottlenecks for service appliances, for example, front-ending spine routers with load balancers and firewall services, and the general problem of not being able to scale well with those old architectures. Therein came the growth of network virtualization overlays. So technologies like GRE, VXLAN, giving the ability to extend layer 2 networks across, for example, a layer 3 class on the underlay. So this enables a more stable network, removing those large broadcast domains, not becoming succumbed to spanning tree protocol and reconvergence and things like that. Also paired with OpenStack, we get more insight and context behind logical networks when tied via SDN through Neutron plugin, for example. So I'll talk about Mesonet, which is a network, a Neutron plugin, and talk about the advantages of a distributed architecture, and then later some operational advantages with Mesonet Manager. So for those who aren't familiar, Mesonet is a network virtualization overlay. It's a complete software play, agnostic to the underlying hardware. And the major advantages are using a distributed architecture to enable layer 2 through 4 networking services. So these include extending layer 2 networks, for example, through logical switching, enable logical routing without the need for L3 agent or a Neutron network node, enabling firewall services like security groups from OpenStack. Also, capabilities of doing layer 4 load balancing and distributing, for example, web services through VIPs. Finally, enabling through the Mesonet API, aligning with the Neutron API to enable these services to be scripted, used with our CLI, as well as Mesonet Manager as a GUI interface. So Mesonet is a distributed controller, so resilient, no single points of failure. Everything's done in an HA manner with production and high availability in mind. So you're not pointing to any service appliance per se. It has that ability to scale because all of the intelligence is at the edge in our agents, and enabling the resources at the compute host to manipulate and provide those layer 2 through 4 networking services. Also, the performance advantages to using the single virtual hop, which enables you to not have to force your traffic to a Neutron network node, for example, or other type of service appliance for higher layer service. So that distributed architecture pushes that SDN intelligence to the edge and allows the power of your logical networks to grow as your workloads grow, so enabling scaling. Growing with the cloud. Also, distributed gateways. So we have basically the ability to scale our gateways, have BGP routing upstream, and you can scale out your gateways to allow for more north-south traffic band flows. So as long as those gateways are reachable on the underlay, you can leverage ECMP to traverse to those gateways and exit the OpenStack Mesonet Cloud through the gateway through BGP and dynamic routing. So if a link were to go down, we're dynamically learning through BGP whether that egress point is available or not. Also, enabling stateful flows through Mesonet allows you to egress one gateway and come back in the other. So sharing of stateful information across those gateways. Also, the ability to exit the cloud for tying the same subnet workloads in a virtual and physical environment. We have layer 2 gateway availability through VTEP. So terminating those VXLAN tunnels on top of rack switch. So those who might be familiar with the OpenStack, basically this diagram depicts how the OpenStack constructs map to the underlying infrastructure. So those might be familiar. Tenant routers can be created. All these logical networks can be created with a varying level of hierarchy based on what the tenant chooses to build. So virtual routers, virtual switches, launching containers, launching VMs, and building those logical networks. So the Mesonet agent, as you can see, the Mesonet logo is depicted where the Mesonet agent is installed. So in this diagram, it depicts Mesonet agents installed on the compute hosts and then also on the gateways, which are just x86 boxes, since we're as agnostic as possible to hardware. All that's required on the underlying hardware is IP connectivity to create the VXLAN tunnels. So that legacy network tool problem, let's talk about what was used in the past and how it doesn't enable us to have insight into SDN and logical networks that are built by users of OpenStack. So previously, using things like RSPAN, sampling through NetFlow or SFlow, just dumping with Wireshark and TCP dump, looking at the packets, we're still going to have that header in front, whether it be GRE or VXLAN, and no context for how those logical networks map to those created in OpenStack. So, of course, blinded by that overlay, no context for these logical networks that are created in the cloud with these traditional tools. So I'll give you a little sneak peek at Mesonet Manager, how it enables you to troubleshoot these logical networks and have insight into each of the logical topologies that are created. So in an older release, we introduced flow tracing, which allowed one to go in, create a filter based on, let's say, tenant, source or IP address, and capture those packets and give you the result of a simulation. That simulation is done on the compute hosts and provides those layer 2 through 4 networking services, whether it be IPTTL deduction, implementing NAT when egressing the cloud, whatever security groups are implemented. In Mesonet, those lower level constructs are called rules and chains. So anything that's applied to the packet through our simulation is spit out here. So in our upcoming release, we're introducing an analytics node, so that's going to give you further insight into what's going on in the cloud environment. So this is enabled just through an ELK instance. Allows you to search based on time frame of any packet that was traversing the OpenStack Mesonet Cloud at any time. So everything is logged and stored and searchable. Makes it really easy for troubleshooting at different times. So we have this sliding time scale to show you the packet flow history, as well as showing that flow trace visualization in the results. So I thought I'd try to give you just a live peek at what it looks like. So you can't see it again. Oh, you can. Okay, sorry. So this is the login for Mesonet Manager. We'll just get in here. So you're presented with the dashboard first, so you get a high-level view of the constructs within the OpenStack Mesonet Cloud. So hosts represent, compute hosts, could be gateways, anywhere where the Mesonet agent is installed. So the introduction of the analytics node enables the flow history capabilities. So here, you go down to the last tab. It's the flow history tab. You can basically add filters to filter out any tenant type network, and based on the result of the simulation, for example, if the security group rule was forcing it to be dropped, you would find the result there. So we have these basic time options that you can look at. So for example, the last week, you can take a closer look. So there's some traffic happening here. You can do like a little sliding window, get a visual of the traffic going through. You can filter, of course, by a logical network device. Below, you can see the packets. So each of these represents a packet flow and the simulation result, whether it's forwarded on or not. So you get a lot of details based of the flow history. So, for example, let's say, just get in a little further. Let's say some monster's lurking in the night and wants to play around, and you see a spike in traffic flow. You can go to a particular time, enter that in, and take a closer look at what's happening. So we'll just get in here. Let's see. So you can basically zoom in and then take a closer look at the traffic flows that are happening. So you can get more results, look at the logical constructs that the packets traversed, and see the final and the final simulation result, whether it's dropped or accepted based on a security group policy. So you can further filter based on a bunch of options here. Let's say we want to look at everything that was dropped in this certain time frame. Just apply that. As you can see, the final results are just everything that you would choose to filter on. So that's just a sneak peek on revealing more of the information, providing context behind the logical networks that are created within OpenStack Mesonet environments. And so for those who aren't familiar, we also have counters, so you get more visuals based on network virtual device. So you can go click on a particular tenant's network or subnets or logical router. Finally, for those who aren't aware, everything underneath the hood there is Mesonet, and it's a completely open source community. So we welcome you to join, be a contributor. We'd love to have you try out our software as well. It's available. So you can check out our website, mesonet.org. And also, thanks for your time. Check out our websites and follow us on Twitter. So thanks for your attention today.